Hey Algebra, it's Friday, the day after your quiz. So today you're going to have two videos to watch and take notes on. I know it's going to seem like a lot of notes, but I want to finish factoring, but I also want to begin solving quadratic equations. So that's why today you're just going to watch two videos and take notes. And then next week we'll do practicing with these two skills. So first thing I want you to do today is you're going to read pages 472 to 475 first, and you're going to learn, and then we're going to talk about the last way of factoring, which was not on the quiz because I didn't want to throw this in there because that would have been a lot. But again, this is the last type of factoring. So if you'll stop and read those pages first and then come back and take notes, and you'll be again submitting your notes as your homework today. All right, here we go. Okay, so first of all, I know you probably are tired of seeing this chart, but again, I told you at the beginning of factoring before we left school that we would make a chart every time we added a new step to factoring, and now today we're adding the last one. So again, you always look for a GCF. After you see if there's a GCF and you take it out, then you look at the number of terms. The number of terms determines what way are you going to try to factor first. So if there are four or more terms, you're going to try grouping. Now, this doesn't mean that once you do grouping, you're done. At that point, there could be a different type of factoring you're going to take into account. If there are three terms after the GCF, then there's always three types of trinomials. There are ones that are in the form of x squared plus bx plus c that has a 1 in front. There are the types of trinomials where you have something other than a 1 in front of the x squared. And there's those special ones that are perfect square trinomials. Until today, if you have two terms, the only way to factor those was if we had a difference of two perfect squares. Today, you guys are going to learn the last type of factoring, which is sums and differences of cubes. And I wrote the word SOAP next to it because that's a mnemonic that's going to help you with these. All right, so here we go. Okay, so the first thing that we are going to focus on today is we're going to talk about sums of cubes, okay? So first of all, it's only going to have two terms if it factors as a sum of cubes. That's the first stipulation. The book says the formula is f cubed plus l cubed factors into f plus l times f squared minus fl plus l squared. Well, to me, that makes no sense unless you know what f and l stand for. F stands for first term, L stands for last term. So if we have a perfect sum of cubes, what it is we are going to factor it into the first term plus the last term times the quantity, first term squared, minus the first term times the last term, plus the last term squared. Okay, now it always makes more sense when we do a problem. So if I give you the problem 8x cubed plus 64y cubed. Actually, I'm going to change that because most of you would recognize there's actually a common factor, and I don't want there to be one for this one. Sorry about that. So let's try again. How about x cubed plus 64y cubed? So the first thing you have to ask yourself is, are these two perfect cubes? Well, x cubed, the answer is yes, because it's technically x times x times x. 64y cubed. Well, of course, y cubed is y. 64, you got to know your cubes here. So 64 is really 4 times 4 times 4. So if I said, what's the cubic root of x cubed? The answer would be x. That would be your first term. And your last term, the cubic root of 64y cubed, is technically 4y. So your last term is 4y. So how do we put this into the formula? So if I give you a sum of two perfect cubes, this factors into f plus l. So the first term is x, the last term is 4y, and then it's times the quantity, the first term squared, x squared, minus the first times the last, which is x times 4y, which is 4xy, so minus 4xy, and then plus the last term squared. So if the last term is 4y, the last term squared is 16y squared. And that's what that factors into. Okay, now that's a lot of remembering and memorizing. Now I will tell you there's a little mnemonic that you can remember just to remember the signs. Unfortunately, it doesn't help you remember the F plus L and the F squared, the FL, and the L squared, but it does help you with the signs. And at the high school, they call these problems SOAP problems. And here's why it's SOAP. It comes from the signs that are in the parentheses. So S stands for same sign. So what's that mean? So if you look at the original problem, F cubed plus L cubed, it has a plus in between it. So in this first parentheses, it has a plus. That's where the SOAP comes from. So in the first parentheses, the sign is always going to be whatever the sign is in the problem, as in the operation, okay? And then if you go to the second parentheses, O stands for opposite sign. So if you look in the second parentheses, right here, do you see how this is a minus? Opposite of the original operation, which was addition, so it becomes subtraction, so that's your opposite. And then AP actually goes together. That means always positive. So where does that come into the effect? All right, so this right here, no matter what we have, whether we have a sums of cubes or differences of cubes, that last sign is always positive. So that's where the AP comes in. So there's SOAP, okay? All right, so let's do a couple more of these because I'm sure that didn't make a whole lot of sense yet. All right, so let's talk about this problem here. 27y cubed plus 125z cubed. All right, so if you think back to your chart from a couple slides ago, we would ask ourselves, is there a common factor? The answer is no. Next thing you do is count the number of terms. Well, we have two terms, so we're going to ask ourselves first, is it the difference of two perfect squares? Well, it's not a difference, so we know it can't be a difference of two perfect squares, plus we don't have two perfect squares. So the other thing is it the sum of cubes? Is it a SOAP problem? Well, we have to say to ourselves, is 27y cubed a perfect cube? Well, 27 is really 3, 3, 3. Y cubed is y. So the answer is yes. It's 3y. 125z cubed, is that a perfect cube? Well, 125 is 5 times 5 times 5. Z cubed is z. So the answer is yes, it's 5z. So in my formula, this is technically my F, and this is technically my L, my first term and my last term. So yes, it is the sum of two perfect cubes. So my formula says, if I go back to the last screen, it says the first term plus the last term. So that's 3y plus 5z. And then the second part of the problem says the first term squared, so 3y squared is 9y squared. Now if I think about the word SOAP, okay, so I know this is going to be in the first parentheses, this is going to be always the same as the problem. So the plus comes from the plus at the beginning of the problem, okay? In the next parentheses, my next sign is going to be opposite. So the opposite of the problem was addition. So now we're going to have minus. So this is going to be minus. And then let's see, the formula says the first term times the last term. So if I take 3y times 5z, that's going to be 15yz. And then SOAP says always positive, so this is going to be plus. And then the last term squared. 5z squared is 25z squared. There's a lot to remember in these problems. That's why I didn't actually put these problems on the quiz. Okay, so that is the sum of two perfect cubes. Okay, so now let's talk about difference of cubes. Okay, so again, going back to our slide before, we always check to see if there's a GCF. If there is not a GCF, or if we take the GCF out and we have two terms, now we're going to see that we could also have something called difference of cubes, which would look like this: F cubed minus L cubed, which means that the first term is a perfect cube, the last term is a perfect cube, and it's subtraction this sign instead of addition. So what's the difference? Well, going back to SOAP, so the formula is exactly the same. okay, except for your signs. So if you notice, where does the soak come into play? So first of all, my sign in my original problem is minus, okay? So in the first parentheses, my S, there's my same sign, so same as the original problem, so it's minus. And then right here is going to be my O, the opposite, so it was minus in the problem, so now in the factored form it's add. And then, of course, the last sign is going to be my always positive, okay? So if I look at this problem that I have right here, 8m cubed minus 343n cubed, I'm going to ask myself, first of all, is there a common factor? There's not. Now I'm going to say to myself, are these two perfect cubes? Well, what times what is 8? 2. So 2, 2, 2, m. So that is a perfect cube, so it's 2m. The last term, 343n cubed. Now again, you got to know your cubes here. I know that 7 times 7 times 7 is 343. You could always use your calculator to find that, but some of these you just need to learn. And then n. So I know that this is a perfect cube and it's 7n. So again, here is my first term, here is my last term. I'm ready to factor it. So the formula says the first minus the last term, so that would be 2m minus 7n. And again, it's the same sign as the original problem. And then my second parentheses, I just can't fit it up beside it. First term squared, so 2m squared is 4m squared. Opposite, so the original problem was minus, so now my sign for opposite is going to be plus. First times last term, 2m times 7n is 14mn. And then plus the last squared, always positive. So plus 7n squared is 49n squared. I think I squeezed that in there, okay? All right, so that's the difference of cubes. So let's do another one of those. So how about this problem, okay? So if we look at this problem, 216x cubed minus 1. Okay, well, there's no GCF between 216 and 1. I have two terms. It's not the difference of squares. Now, granted, 1 is a perfect square, but there's a cube involved, so I know it can't be the difference of two perfect squares. So now I'm going to ask myself, are these two perfect cubes? Well, think about this. Some people would go, no, but it is. Think about, what's the cubic root of 1? 1 times 1 times 1. Okay? And then, so my last term is going to be 1. 216x cubed. Now, you got to kind of mess around here and think about this, but it's actually the cubic root of 216 is 6. So 6 times 6 is 36, times 6 is 216. And then x cubed is x. So my cubic root of 216x cubed is 6x. Okay? All right, so since I found that it is a difference of two perfect cubes, so that means that this 6x is my first term, and the 1 is my last term, and it's the difference. So that means it's going to be the first minus the last, because it's the same as the actual problem, the same operation. So it's going to be 6x minus 1. And then this parentheses is the first term squared, so 6x squared is 36x squared. Okay, and then opposite, so the original problem was a minus, so opposite means it's going to be a plus. Now we're going to take the first term times the last term, 6x times 1 is 6x. And then always positive, so this is going to be plus, and then the last term squared. 1 squared is 1. So that is what 216x cubed minus 1 factors into. All right, so now how can we put this all kind of together a little bit? So what if I gave you this problem? And you've seen some of these numbers already. Okay, so in previous problems, we've already learned that 27 and 216 are perfect cubes. But that doesn't mean I'm going to jump right to this and say, okay, I'm ready to factor. Because guess what? There's actually a GCF in this problem. Yeah, you got to figure that out. And I bet some of you, this is what you would do. I'm going to show you. So I bet some of you would say, oh wait, there's a 3 in common. So if I take a 3 out, this is what I get. Okay. And some people right there would jump to, okay, can I factor it? What can I do? Well, if you notice, it's not perfect cubes now. So that must mean that I can't go any farther. But if you notice again, look, these two have another common factor. So I didn't take out the complete common factor. They now have not just a 3 in common, they have a 9 in common. So watch what you can do here. So I see that these have a 9 in common. So I'm going to pull the 9 out. So we already pulled a 3 out. Now we're going to pull a 9 out, and this is what I end up with. Okay, so my answer is 27 times x cubed minus 4y cubed. Now, some people at the beginning of this problem would have said, oh, I knew that they had 27 in common, and if so, that's great. But the mistake some people would have made in the beginning, they would have said, oh, this factors into... Okay, so I'm going to just make this to the side, and I want to show you this is wrong, but this is what some people would think. So they would say, oh, so this is 3x for my first term, and this is 6y for my last term, and this is how they would factor it. 3x minus 6y, okay, and then times, let's see, the first term squared is 9x squared, and then it's opposite, so plus the first and last term multiply, 18xy, and then it is always positive, the last term squared, 36y squared. Okay? And some people would factor it like that. Well, here's the problem. If you look at this, this isn't the factored form. And here's why it's not the factored form. You have a common factor here, you have a common factor here. So if somebody did it that way, they missed the entire problem. There's no way to fix it. So that is showing you why it's very important that you have to find the common factor first. Because when I get down to this answer right here, I can't go any farther. Even though x cubed is a perfect cube, 4y cubed is not, and it's not the difference of two perfect squares. This is the answer. Okay, so I just wanted to point out to you that this is why you have to be very careful of finding the GCF, because a person that wouldn't have found the GCF in this one, they would have had a totally wrong answer over here. Okay, so I just wanted to kind of point out to you, this is why we have to be very careful at taking the GCF out first. Okay, just to make sure we understand these two types of factoring, I'd like you to do both of these right now. When you're ready, come back and I will go over them. All right, so let's see here. Number one, I know there's no common factor. Are they two perfect cubes? Well, the cubic root of 8x cubed is 2x, because 2 times 2 times 2 is 8, and x times x times x is x cubed. 729, that was a tricky one. 9 times 9 times 9 is 729. So yes, it is a perfect cube. So here is my first term, here is my last term. So you should have 2x, and then the original problem was a plus, so the same operation is plus 9. My parentheses, first term squared is 4x squared. Opposite operation, minus, first times last, 18x. Always positive, square the last term, 81. So that's what you should actually have. All right, problem number 2. Is it the difference of two perfect cubes? Well, first of all, there is no GCF. So 64. 4 times 4 times 4 is 64. So yes, 4m. 27n cubed. 3 times 3 times 3 is 27. So 3n. And it's the difference. So here is my f. Here is my l. So this factors into 4m. Same operation. Minus 3n. In the parentheses, I'm going to square my first term. 4m squared is 16m squared. And then opposite, so it was minus in the problem, so this is going to be plus. First term times the last term, 4m times 3n is 12mn. And then I have to do always positive, and I square the last term. So that's 9n squared. Okay, so hopefully you can read those. I'm sorry, they got a little messy there. All right, so that ends the notes for the last type of factoring, which I call SOAP problems, or you could call them cube problems, whatever you want to call them. So what you're going to do now is you can just add on to your notes. Now you're going to move on to the next section, which is learning how to solve quadratic equations by factoring. And what you're going to find out is we can solve them by factoring, we can solve them by quadratic formula, or we can solve them by graphing a parabola. Hopefully we can get through all three of those things before May 15th. Okay, so please go ahead and watch the next video. I know this is 2 lessons in one day, but I know you guys can handle this. All right, so see you in a minute.